want to talk to you about vectors, and specifically how we represent vectors with arrows. So imagine we had a vector that was 4 newtons to the east, meaning its magnitude is 4 newtons, its direction is directly east. We can represent that with an arrow that might look like this, 4 newtons. And that's a force, so that's a force that's pushing to the east with a magnitude of 4 newtons. Let's say we took that same vector and we decided instead to make it face north. We might just represent it with an arrow that looks like that instead. Sometimes we're going to draw these vectors to scale, sometimes we're not. Sometimes we can do quick sketches like this, sometimes we need to do detailed sketches. So let's talk about how we might represent a vector that is drawn to scale. I'm going to just make up a vector that is going to represent, let's say, 200 meters is a vector, and I need to make sure this is a vector quantity, so I'm going to call this displacement. So the displacement is 200 meters at an angle, and so the angle defines our direction. This is our magnitude. Now our direction, our angle is going to be 30 degrees north of east. So often we will measure angles from the east. We can measure them from different directions as well. So let's figure out how to do this. Let's just start with a point right here. This could represent our starting point. Technically, a vector can start at any location. You can move them around if you want. What's most important is how long is it? And that is represented by the magnitude. And the angle would be the direction. If I want to draw this, I might want to define a scale as well. So in my scale, I'm going to say 1 centimeter. This is just like doing a map where you have a legend and a scale on it. 1 centimeter equals 2 meters of displacement. You can do this with forces as well. You can say 1 centimeter on the map equals 2 newtons if our vector was a force in newtons. I'm going to do this with centimeters and meters just so you understand that this is our vector and this is the scale that we're using. So if we're drawing something that is 200 meters long at a scale of 1 centimeter equals 200 meters, per the scale, the vector should be 100 centimeters long. And we know the angle is 30 degrees north of east. So I'm just going to lay down an x-axis here that goes through the starting point. So the x-axis shows us east and west. And I want to find a direction that is represented by 30 degrees north of east. So to find this, we look east and then we go 30 degrees to the northerly direction. So that's 10 degrees, that's 20 degrees, that's 30 degrees. So that direction right there would represent 30 degrees north of east. So I could draw a vector in this direction. That is 30 degrees north of east. Now I just need to make sure it has the right magnitude based on the scale and the magnitude that we've been given. So if the scale is 100 centimeters equals 200 meters, that means that this vector right here should be 100 centimeters long. That is the length of this meter stick. So this is the ending point right here. And when I get to the end of the vector, this is very important, I'm going to draw an arrow on it, because the arrow indicates the direction. If I had an arrow at the other side, it would indicate a vector that had the same magnitude, but pointing in a different direction that was 180 degrees shifted from what this is. There are a couple parts to this vector too. So imagine this is a vector, this vector is like an arrow. If you were to draw an arrow, like a bow and arrow, that might have a tip. And at the bottom you would have feathers on it, and those feathers would represent the tail. So this vector as well has a tip right up here and has a tail down here. There's an arrow, it's the correct length, and it's at the correct angle of 30 degrees from the easterly direction. Now, if we were to measure it from the north, which is possible, because you're looking at a right angle between north and east, this angle would have to add up to 90 degrees, so that would be measured as 60 degrees to the east of the northerly direction. So there are lots of ways to measure, but most often we will measure from the east. Thank you very much.